From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 385, recorded live Thursday, August 8th, 2013. Support for Hansel Minutes is provided by Telerik, offering the best in developer tools and support, online at telerik.com, and by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with open source developer Jan Lehnardt about the NoSQL movement and CouchDB.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and on the Skype right now I've got Jan Lehnardt from Berlin, Germany. How are you?
Hey, I'm fine. How are you?
I'm very well. Thanks for waking up with me this morning. I'm up at midnight and you're up at 8. That's lovely.
Yeah, it's not my time, but I'm happy to be on the show.
That's great. You're known in open source spaces. You've done Mustache and CouchDB, which is what I'm interested in talking to you about.
Yeah.
So, NoSQL, this is like the hot thing that everyone talks about, but I think people who are listening to the show, and myself included, are used to like kind of classic SQL databases, entity relationship diagrams, spending lots of time looking at designing schema. This is a whole different way of thinking about it. It's the exact opposite, isn't it, of a relational database?
The aspect you mentioned of NoSQL, definitely, that people can be freer in doing software rather than planning it and then maybe doing it later when the plan got approved or whatever. But pinning a specific attribute to NoSQL tends to be very hard. So it can be about scaling, about ease of use, about the schemalessness that you mentioned. And there's all sorts of other stuff that NoSQL is known for. It's kind of like a big hodgepodge of things. But yeah, it requires some rethinking of what you may have learned in university or on the job.
Is it a matter of taking characteristics that we think of in a classic SQL or relational database and just doing the opposite? Or what are some characteristics of NoSQL databases?
It's more like going back to the fundamentals of data storage. So all major databases work the same way. There's some tree-like data structure for main data storage and indexes, and then maybe some hashes for specific purposes. And then the NoSQL database or NoSQL databases just take the same underlying technology and put it together in different ways. So there isn't anything new in NoSQL. Maybe the putting things together in a more specific way, and maybe introducing a bit of distributed systems thinking into how to build larger databases that then fit in the single machine. But the underlying technology is basically the same. So it's not all too different for me. But like I've been at it for a couple of years now.
Well, when you say that the underlying technology is the same, you're saying that things like indexes and record retrieval, that those concepts are still fundamentally there.
Yeah.
So, I mean, I'm pushing data to it. I'm doing inserts. I've got indexes. I have views. Data is still data. For loops are still for loops, of course.
Right. Yeah. That is basically it. And then the difference is that maybe on the insertion in the SQL databases, there's the SQL database will look up the table structure and then enforce the particular schema. And a NoSQL database may just take the data you have and store it as a JSON blob. But that's not any different from storing a JSON blob into a large data structure in a regular database.
Right, but if I took a JSON blob and threw it into a column in a standard SQL database, I wouldn't be able to query what's inside that. It would become this opaque bunch of bytes.
Right.
And SQL databases don't like doing that, too, because it's unbound in its size. And SQL databases seem to like their slices nicely paged.
Yeah, that is correct. And yeah, there's a bunch of optimizations that if you can do if you're very, very sliced or very, very record oriented. And then there's the orthogonal version, like the Verticas of the world, which are the column databases, which slice just the other way, which is probably orthogonal or something. And then in the NoSQL world, we tend to not worry too much about that because if you introduce this idea of scale, the individual single query performance may matter less than the overall system throughput. So if you have 1,000 machines running a single database, making sure they all respond to the request in a reasonable amount of time that's still fast enough for the user, that's good enough, then squeezing the last microseconds out of a single query.
That's interesting, because I know that when dealing with classic kind of SQL Server, and I come from the Microsoft SQL Server world, but I've also done work on DB2 and I've done work on Oracle databases. Scaling up is always easy. Going from 1 to 4 to 8 to 16 processors is what SQL databases and SQL database administrators like to do. Throw memory at it, throw processor at it.
Yeah.
But you're saying that in the NoSQL world, that chopping things up and scaling out rather than up is more appropriate?
Yeah, there's definitely a bunch of databases in the NoSQL world that are based around the idea that you can just throw more hardware in terms of more machines at the problem.
Mm-hmm. So if I were going to do the standard make a table of people, how do I store people? Do I create a table and create columns and give those columns data types?
Okay, and now we need to look at what specific NoSQL database you're looking at. There are different versions. The one I'm working on, Couch, and other ones of the same idea. You just have a record of just a JSON blob that contains the data that you want to store. That is name, first name, last name, age, address, whatever you want, and you just store that into the database. And there may or may not be schema enforcement there. If you have other databases, say like Cassandra, you want to have some ideas about the types you're going to be storing because the system's going to do stuff with them. So this is where the term NoSQL breaks up a little bit. You need to look at the specific database you're storing data with.
Okay, so let's talk about CouchDB. Can I just throw it some JSON that looks like a person and it'll just say, all right, well, that's a person. I'll hang on to this for you for later.
CouchDB will actually just say, oh, that looks like valid JSON. I'll hang on to that for you. And it'll give you a key back, and then you can use that key later for retrieval. And then on top of that, you can also create indexes for the specific properties of that JSON blob. So if you want to look up people by first name or last name or age or something like that, you can create secondary indexes to retrieve that data as well in a more query-like way.
Now, when I'm doing things to SQL servers or oracles and things like that, they all have a socket that they open and they have some magical binary format. Am I speaking some secret format, or am I just posting JSON to an HTTP endpoint?
That is exactly it. CouchDB is all built around the web and web standards, so it speaks all HTTP and JSON, and you don't need any special software to use it, like curl or a browser will do. Like, in fact, the admin interface of CouchDB is just like a web app that uses XHR to talk to CouchDB. There isn't any middleware that does anything fancy.
So I could write my own if I wanted to. I mean, it's just a web service out there in the world.
Yeah, that's one of the banes of CouchDB's existence. We kind of decided not to write client libraries because you don't actually need client libraries. So the first thing everyone does is write a CouchDB client library for their needs. So there are a million of them that just do that thing they need, but none of them do everything everyone needs, and that's kind of an issue. But it's also fun that people just write their client libraries because it's so damn easy.
Interesting. That's actually the next question was like, okay, I'm a .NET programmer and I'm thinking I want to start doing work in CouchDB. Should I go and hunt? I mean, I would naturally go hunting for the official .NET client library, and it just doesn't exist.
Well, there's like, I'm going to say wiki and everybody's going to hate me because wikis are awful, but we're collecting these, and then there's a bit of a natural selection going on, and the better ones tend to pop up to be on the top of the list on the wiki. So there's some hunting that you can do and reuse of code you can just get into for easiness, but then like if they're good, they're a really thin layer on top of Couch anyway. So if you want to learn Couch, it's probably really easiest to just write your own and just keep going with it. But if you just want to get stuff done, you skip that and take one of the existing ones.
So it's definitely a database where I need to love the web in order to love Couch.
Yeah, but you should love the web anyway.
Okay. So I've got my person, my first name, my age, and all those kinds of things. How do I go and say, well, give me all the people with the first name that starts with S?
All right. So here's the thing that's most tricky to explain in CouchDB, I guess. The way we do querying is a bit obscure, but it works quite nicely. We're using a procedure called MapReduce, and now everybody runs away screaming again. which requires you to write some JavaScript, which if you're a .NET programmer, is probably not your favorite thing to do, but you can still do and manage. And usually the code required to be written is really, really tiny, just a couple of lines of code. So basically all you do is write a function that gets applied to all your records, and all it needs to do is emit or return the data that you want to be in the index. So if you want to have the first character you said of the last name, right? Mm-hmm. So you just emit or return the last name from that function, and then you get an index by last name, and then you can do a subquery on that query time, just like give me everyone that starts with a T.
Mm-hmm. So I would make a function that takes a doc, and I would do whatever I want to within there. In this case, say, if, and then go off looking at index of.
Oh, so you wouldn't, in the map function, you wouldn't program your query details in as, like, extract the first character of it, maybe. But maybe you want to have an index by last name, and then there is, like, the indexing time and the query time. So at query time, at indexing time, we create an index. So we put all the last names into a data structure that's really efficient to look at. And then at query time, we can say, within that data structure, give me a subset of the rows there. And then you can say, just give me everything that starts with a T, or everything that's in between starting with a T and starting with a S, excluding the ones that start with an S. So that's everything with a T. But the same index can also answer, just give me everything by last name.
I see. So if I understand correctly, hence it's map reduce. First, I decide what are the records I want to map this on top of, and then I reduce the result. So I would go in almost like I'm getting a view model, not the actual data, but a view on that data of last names. That's one function, the map function.
Right. Ignore reduce for now. I think it's too much for a half-hour
podcast. Okay, but then I query that resulting view.
Yeah, exactly. And this mechanism is called views in CouchDB, so that's very fitting.
Mm-hmm. And will that be familiar to MVC people, or is that just a coincidence that it's called a view?
That's a different kind of view.
Okay.
Yeah.
Okay. And so this emit function, this is a fundamental built-in function that takes this key value pair.
Yeah.
And the key is some arbitrary key, or is it a meaningful natural key?
It is whatever you want it to be. We usually use, at least for the secondary indexes, use some natural data, like the last name, the age, the street, or whatever you need.
Mm-hmm. Does it have to be unique?
It does not have to be unique. In fact, there is no unique constraint even possible on the secondary indexes, which is a bit of a limit, but we may be able to fix that sometime later.
Well, actually, speaking of limits, one of the things that you say, just a couple of chapters into one of the, what's the deal with CouchDB wikis, is that there are some limits that will initially make newcomers feel that it's inflexible, but then after some work, you go, oh, I see why you did that. That's a useful limit. So what is something that would turn me off and immediately make me think, this is so inflexible, but it makes it possible?
Right. So this is where we maybe talk about the reduce a little bit. If you want to score somebody, like you have games and people have scores, and then you want to find out who has got the highest score, right? So you can use the map and the reduce to compute the score of everyone, but you can't sort by the score anymore. That will be a chained map reduce, and we currently don't support that because very fast access to a chained map reduce, like an OLTP style access to a chained map reduce, isn't really possible because you need a table scan style computation of that result. So what CouchDB gives you is a list of all the scores, but you need to sort them in whichever way you need in the client application, which may seem very inflexible and very silly, but it allows CouchDB to be deployed on multiple machines and guarantee fast response times at all times. Whereas with other systems, you will get into a situation if there's a lot of data in that kind of query, you need to bump some buffer or run into some other like memory issues. And CouchDB just doesn't give you that feature to like shoot yourself in the foot.
So in a kind of a classic SQL database, you would find out later that something was a table scan. You'd do some profiling and you'd go, wow, why is that so slow? Oh, that query turned into a table scan. And then you have to go off and figure out why that reduced into a table scan. You're saying that CouchDB simply won't allow you to get yourself in that situation.
Right, yeah. I think for the most part, all the features in CouchDB are built in a way that don't come haunting you later.
Mm-hmm. But then that means that the logical operation may need to be split in its responsibilities between, some middleware that might do some additional filtering or some additional sorting.
Yeah. That is correct. And we were very hardline as part of the development team to not ever have features that are like that. We're kind of like switching the whole like development and code structure to a small core and many plugins kind of thing. Because we found that people really want to have that problem solved rather than not being told they need to solve the problems differently. So maybe we'll have a plugin that allows you to sort by reduce value. With the caveat that it may break later. But if you make the conscious decision of okay, I'm using a feature now that I know might break, but I'm never going to be in the position where it actually is going to break, I'm able to use that. So we're kind of starting to turn around on this one.
Mm-hmm. Now, if I was going to have some values that are dates or something that's a little bit more formal than a string, and I've got a bunch of people, but instead of sending in birthday, let's say one of the records I just put in some nonsense language, something that's not a date. So I've got birth date equals foo. What is the database going to do with that? Is it going to reject it, or is it just going to say, "Hey, I'm relaxed, I'm chill, I'm CouchDB"?
Yeah. CouchDB is definitely relaxed. As long as it's valid JSON, it will just accept it and store its data. Whether the data makes sense in your view definitions later, or say you're accessing a field in a map function that doesn't exist, that may throw an error, or your client-side code or your middleware code will expect that kind of data is different matter. But then there's a way in CouchDB to enforce schema as well, which may sound counterintuitive because of one of the whole ideas of NoSQL not being schemaless and all. But you can tell CouchDB once you've figured out what your data is going to look like to reject data that doesn't look like the one that you've defined. So it's kind of like I like to think about it as static typing versus dynamic typing, and then CouchDB also allows you to add type hints, basically.
Right. Okay. That type annotations. I think about when I explain TypeScript to people, they immediately kind of recoil in fear. What have you done to my JavaScript? But then you explain, well, it's thrown away. It's not really used. It's just there as a sifting filter to prevent you from hurting yourself.
Right, and then the only difference there is that filter in CouchDB is a hard filter. If you're trying to store some data that doesn't conform to your specification, it will not get stored.
So it's a filter on the way in.
Yeah.
And if you've already got data that's bad on the way in and you want to clean it up, you would want to pull it back out and then put it back in again.
Yeah, the client will get a rejection and say, "Hey, this doesn't look right," and then you can look at the definition and change whatever needs changing and fix it.
So the term NoSQL. It means there is no structured query language. There is JavaScript. I'm using JSON for my storage, but is it really JSON on the disk, or is it some magic sauce that is not JSON?
For all intents and purposes, it is JSON on the disk, but then it is the Erlang representation of JSON, because CouchDB is written in Erlang, and we're doing a type conversion internally for various reasons that elude me at the moment, and we may get rid of that eventually. But we're storing the raw data just on disk as is.
So if I have a database, a CouchDB database of all the people in the world, which is going to be quite large. Let's say it takes, 10 computers. Am I chopping it up like the Yellow Pages, where I have A through F on this computer and L through Z on that computer? Or how is that across multiple? How do I do that? How do I do something so big?
So it again depends a bit. I'd also like to think of CouchDB as a toolkit to build your own distributed database, which is only interesting to people who like building distributed databases. So you can think up your own partitioning scheme if you want, by name, and then your box for the letter S needs to be really big in certain groups of people. The other way around is just letting software do the job. There is the quite famous Dynamo paper by Amazon, and there is an implementation of that paper as kind of an add-on to CouchDB that allows you to just specify or say these 10 computers now behave like a single CouchDB, and we'll do the partitioning for you. And we're in the process of merging that plugin back into CouchDB proper towards the end of the year, I guess, where we'll be done with that and have that released. So you don't actually have to worry about anything. You just add another machine and then things get spread out.
Mm-hmm. So then who am I asking? Am I asking some load balanced endpoint over HTTP? Give me all of the people who are over 20 years old?
In that case, all the nodes in that database will act as a proxy. So if you can ask any one node and hey, give me that record, and if it is that record locally, you'll just return it, and if it doesn't, it will proxy the request to the node that does have it, because every node knows where every other key lives.
Ah, interesting. Okay. So then how does that relate to something like a Redis or a Memcached? I feel like we're blurring the lines a little bit.
So for Memcached, and both Redis and Memcached are fundamentally single machine databases or programs. And then there's some best practices around Memcached, how to get it to sharding. There's every client library has the shard key kind of thing, so you can have 3 machines that are in Memcache, and then whenever you have to add a Memcache machine, you have to reshard everything because you need a new key that distributes it over 4 and so on. So that's a bit annoying. Redis are working on a cluster feature that I haven't looked into very detailed yet. They're like the storage engine to CouchDB that is fundamentally single server, but then a layer on top can do the distribution for you.
Okay. And trying to think about how I want to phrase this. Do you think that there is increased legitimacy in the kind of the classic enterprise of NoSQL because of the success of things like Netflix? Or, I mean, is Couch too relaxed for a big enterprise like some boring insurance company somewhere?
So CouchDB is used in the enterprise and boring media companies, at least that I know of. Like the BBC is using it, and one of the bigger German broadcasters is using it, and a bunch of others. So there's definitely big names using the software. And I think the bigger question here is, does it solve a particular problem better than existing solutions, and does it have a low risk profile? That's the biggest thing for the enterprise, I guess. And CouchDB in particular is an Apache project, which a lot of people think of kind of like the place where open source projects go to die. But that's kind of not the right thing to think about it.
I think of it as a place where they go for legitimacy.
Yeah, exactly. That's more like it. Apache puts the community around the project first and visibility into that community first. So a big enterprise will know way in advance if something like big disruptive is going to happen to the project, if development is going to slow down, or if big changes are coming, because everything is in the public and guaranteed to be in the public. There's not one single company that is behind the development that then suddenly says, hey, we're doing something different today, or version 4 breaks all backwards compatibility. Good luck, and supports for the other one stops right now. That kind of thing. That said, though, the proper support and the support contracts and services kind of thing needs to be built on top of that by other people. So there isn't that package that you can buy as an enterprise. But there are some folks that provide that service.
Mm. So let's talk about performance. One of the things that it's kind of touted as is it'll slow down, but it won't fall over. Like, if you start throwing a lot of work at CouchDB, it will just maybe take a little bit longer, but it doesn't tip over. Is that true?
Yeah, that's about it. My friend Max Ogden phrases it like you pay all the hurt with CouchDB up front, but then it never gets any worse. Whereas with other databases, they are really fast at the beginning and then they get slower over time. Kind of like that. Like we're basically operating at worst case scenario at all times.
And why is that? Is that because of Erlang just does well on multiple cores?
There's multiple things that attribute to it. Erlang is actually definitely one part of it. It doesn't optimize for the single request performance, like I mentioned earlier, but for overall system throughput and making sure you have always like saturated I/O and be able to accept all the incoming requests as sockets and that kind of stuff. And if everything takes a little longer, that's no problem. But then if there's like a spike of 10,000 requests coming in, it'll just handle that gracefully. And it's really hard to build that into other languages to deal with these spikes really easily.
Well, don't big databases fall over when it comes to things like contention, where everyone's trying to get to the same page at the same time, and that's a computer science problem, not necessarily a language or programming language problem. Why is CouchDB different?
So in the getting to the same record kind of scenario, we'd do the proper computer science thing and then leave it to a caching system that will be in front of CouchDB, which is one of the beauties of using HTTP as a protocol. We can just use any of the proxies that are available for that, and they all work really nicely. So we just don't solve that problem.
Now that's interesting. Let me interrupt you before I forget. So you're saying that because HTTP is the transport, you're not just using the URL style, you're not just using HTTP verbs, but other things, e tags and not modified and things like that. That's meaningful as well.
Yeah, that's correct.
Okay, that's a really important point for people to understand.
Yeah, and there's one of the neater features of CouchDB is a real-time feed of stuff that happens in the database. So we can have like a live update of caches. So invalidate that key right now because it's not valid anymore. So we can, for hot data, we can preemptively update it for the cache, or just at least tell the cache you can evict that particular key now.
Mm-hmm. And what about like big bulk document inserts? Is this something that's just for little records and stuff, or if I was going to go and do big bunches of information, or maybe throw in some binaries, some pictures, and some PDFs and things like that?
All right, cool. That's two questions. One, the bulk insertion is a feature. We have just a post endpoint that just takes a specifically structured JSON that isn't standard or anything, but it's very trivial. It's just a list of documents, basically. And you can throw it at CouchDB and we'll just store it in bulk, and it will be faster than like storing every single one on their own. And the other question was with binary data. CouchDB has this idea of attachments, and if you've ever done attachments in email, which everybody has, you already know how it works. It's a list of keys or like key value pairs attached to a document that is just a name and a type in a blob, and you can have as many of you as you like.
There's some other databases in the world that also have the name Couch. And I don't understand. There was one CouchDB, and then there's CouchBase. These are different things. Is that right?
That is correct, and it's a bit of a unfortunate history. But let me explain. CouchBase came out of a merger for a company that was doing CouchDB development called Couch1, and a company that was doing Memcache, Membase-y kind of things called Membase, and they merged into a thing called Couchbase and named the company and the product after it. And Membase is actually, we talked about Memcache earlier, is the codification of best practices for Memcache servers. So it just implements a sharding scenario where you don't have to reshard every time you add a new system or like a new machine to the whole cluster. And it does that very well. It also adds persistence. So when you lose a machine and then it restarts, maybe you don't have to load the data from all the other machines. Memory, because if you're in a failure scenario, there's a lot of errors going on. You don't want to have extra load repopulating a new node, so it can just read from disk and it's online again, and it also allows you to store more data than you have memory available for. And at some point they were using SQLite as the backend storage, and they thought that's not very flexible because they couldn't, it was working very well as a key value store, but not for dynamic queries on the things that we're doing, and they thought CouchDB was the better backend for it. So these companies merged the products, and CouchDB-like technology is now behind Couchbase. But the thing that are defining for CouchDB, the HTTP, the storage, and the multi-master replication feature, which I'd like to talk about a bit in a second, aren't part of Couchbase as is, which adds part to the confusion. To save their honor, Couchbase did plan to make it look like a CouchDB, but just engineering reality made it not work out that way. So they focused on the thing that they could ship in time to make their customers happy, which is CouchDB in the back and Membase in the front. Okay,
but they don't share any code.
There's some code there, Couchbase is also an Erlang and C hybrid. All data is done in C and all management is done in Erlang. So there's some code that is shared, and but ultimately they're different systems.
I see. And they're both named Couch, and that's unfortunate, but they're different things.
Yeah, it's a historic accident.
And then what was the other thing that you said that you wanted to make sure we talked about?
The replication feature. If if people ask, what's the one, like, why would you use Couch? And there's the one defining feature that everybody agrees is the one thing that is CouchDB is famous for. And we call that replication. Other people know the same thing as sync. And, well, you know database replication from other databases, but ours is a little bit different. And I kind of think of it as like the Git of databases, or it does what Git does for your application data. And not in the sense that you have like a lot of diffing going on and merging stuff, but more, I have a local copy of my data, and I want to show you what I have, and then I can replicate it to you, and now you have the full set of data as well, and you can look at it, and you find a bunch of issues with it, and you can fix it. And then I replicate your changes back, but you also showed it to your friend, and they found a bunch of issues or added a bit of data, and I can get both your stuff back into my copy, and if we think it's all good, I can push it to a live server, and then my continuous integration will pick it up and check all the data again without our automated tests. And when that's all okay, it pushes it to the production system. Like kind of how you think about doing code deployment with Git, but for your application data. It can live everywhere. And that's pretty cool. And fairly unique to CouchDB.
And how much of that is automatic, kind of imposed workflow versus are those methods that I call, or how do I make that happen?
So the fundamental procedure is very limited. It's just replicate this database to another database, and this database can be a local or remote one, and the target one can also be a local or remote one. So it can go either way, whichever way you want. And then whatever management you want on top of, like automation, automatically push everything. There's some hooks for that, but usually you script that yourself.
And do I just declare one authoritative because I feel like it? Like, Linus owns this Git repository because he's Linus, because we said so. Or is there a formalization of who's on top?
No, that's ad hoc. Like whatever you want to be, the master is the master, or there's no master if you want that.
Very cool.
Right.
So people can go up to guide.couchdb.org, and is the whole book up there? The definitive guide?
Yeah, that was a very sweet deal that O'Reilly allowed us to do. We were writing the CouchDB documentation anyway, and we told them, like, we're not going to write it twice, so you better let us open source it. And they're like, yeah, that's cool. And we're like, oh my God, it works. Cool. So the book is open source, the whole book.
And it looks like it's a work in progress. You've got English, German, French, Spanish. You've got an English draft that's being worked on, and people can submit corrections as well if they find any problems.
Yeah, it's all on GitHub. You can fork it. It's going to be part of the official CouchDB documentation too, so a lot of more people can look at it as well and submit new ideas or error corrections. And then every major version, O'Reilly will just take a cut and print a book or provide an ebook that they can sell then.
Mm-hmm. And a lot of the people who are listening to the show are .NET people or Windows people. Can we use CouchDB on Windows?
Yeah, of course. Erlang support for Windows is very, very good, and CouchDB support as well. So we ship a Windows binary with every release. You can just, like it's an installer thingy, and you can just double click and install.
And it just runs as a Windows service and does its thing.
Yeah, or there's some configuration there, but I think the minimum thing you want to do is run it as a service.
I see. Very cool. And it looks like there's lots of public C# libraries. If I don't want to just talk to it myself, there's Relax and there's Sharp Couch and things like that. But like you said, I can just talk to this with an HTTP client and build my own wrappers, whatever looks like my data.
Yeah.
Very cool. Well, thanks so much for chatting with me today. I really appreciate it.
Well, thanks for having me. This was fun.
I'll put up all of the links to CouchDB and the guide up on the show notes. This has been another episode of Hansel Minutes, and we'll see you again next week.